Exponential equations, D. What's our first step to solve? We're going to take the log of both sides because can 2 and 7, can we use our gold paper to rewrite them as the same base? No. 2 to the first, 7 to the first is the best you can do. They're not going to be the same base. So we're going to take the log of both sides. Log of 2 to the 3x equals log of 7 to the x plus 1. Okay, that was step 1 yesterday. After we took the log of both sides, then what did we do? We moved that power out front, right? We used our power property. So on the left, we're moving the 3x out front. So then it becomes 3x times log of 2. On the right, we're moving the x plus 1 out front. Keep in mind, x plus 1 is 2 terms being added, right? So I'm going to put x plus 1 in parentheses. So x plus 1 times log of 7. Okay. This example is similar to C in that we had exponents on both sides, x on both sides. Thoughts of where to go next? Okay. In order to get the x on both sides, I mean, there's technically multiple ways you can do it, but what I'm going to teach is that we're going to take this log 7 and we're going to distribute it to the x and to the 1. So then we'll just have terms that we can add and subtract around. So 3x log 2 stays 3x log 2. Log 7 times x, I'm going to write x times log 7 plus 1 times log 7 is just log 7, yes? Okay. An x term on the left, an x term on the right, a non-x term on the right. What's next? Not divide it. Okay, x log 7 is being added to another term. So we're going to take this x log 7 and we're going to subtract it to the other side so that it will join our other x term. So I'm going to subtract x log 7. On the left, I have 3x log 2 minus x log 7 equal to log 7. Okay. Okay. Okay, we need the plan on the left now. We've got both x terms over there. Can I actually subtract those? That'd be too easy, right? Be nice, but that'd be too easy. So I can't put those x terms together. What do I do? Okay. Since both terms have an x, okay, that's our GCF. We're going to take that x and we're going to factor it out. So when I factor this x out, now, keep in mind, this first one is 3 times x times log 2, yes? If you take the x and you factor it out, what remains? 3 log 2 minus x times log 7. If you factor that x out, you're left with log 7. And still equal to plain old log 7 on the right. Okay, we're almost there. If it's x times that big old nasty parentheses, doesn't matter what it is, right? It's x times something, we're going to divide. So I'm dividing by 3 log 2 minus log 7. I'm going to write it on both sides. Dividing by 3 log 2 minus log 7. Okay. I don't know if you necessarily need to write it out again, but what I'm going to be putting in the calculator is log of 7 divided by 3 log 2 minus log of 7. What's going to be the catch to get this right? You're going to have parentheses around that denominator, unless your calculator is a calculator that automatically makes it a fraction. Okay, like some of the Casios basically is what I'm referring to. You might not need parentheses there. The TIs, you're going to need parentheses on, I even tried using the fraction button, which I never used, but I didn't make it work, so. By the way, I'm getting ready to change the TV screen. Did everyone figure that out? Did everyone sing the song?
I do. It's Lady Gaga.
Patrick's not the only one that knows it.
I just didn't sing it.
I've used it before. Yeah, Bad Romance. I couldn't come up with the name until you said it. But.
That I know of. No, it's square. Look at it.
I know, but even with the square. The Roma. Exactly.
Is that what?
The Roma.
Well, I think that's because you distribute the Roma to the 1 and then to the ma. So there's a Roma and then a Roma ma, if that makes sense. I don't know. Okay. Anyways, I can come back to that later. We're in the middle of notes. Maybe I don't even need this screen. Oh, well, it doesn't. You're not going to get this screen if I don't turn on my Elmo. Okay, you guys got an answer by now, right?
I got an answer, but I love drunk.
Well,
What'd you get, Patrick?
Start.
14.57?
Yeah.
Okay. It's right. It's right. You got it right.
okay, well, I'm going with multiple people are getting it, so it should be right. Log of 7, I'm going to, in my parentheses, divide by, I have multiple pieces in the denominator. If you have multiple pieces in the denominator or multiple pieces in the numerator, you use parentheses around it. So parentheses, 3 log 2 in the parentheses on the 2 minus log 7 in the parentheses in the other parentheses. And, okay, it was 4 decimal places if you remember from yesterday. So 14 point, what? 5727. Okay, that's your refresher. Okay, that's your refresher on exponential equations. Remember the top part of that paper yesterday? Or top part of those notes? We used the gold paper. We asked ourselves, can the base be the same? I can't guarantee Savas is going to ask you that, but you can always think it. If the base can't be the same, we took the log of both sides. And I know it was pointed out later in the day that like on A and B, they said, well, could you use a left, right, middle? Technically, it could work. But here's my thing. I'm trying to give you one process that works for all problems. Okay? And so taking the log of both sides is what you'd have to use on C and D, which is why I did that. Okay? Backside. We are solving log equations now. Okay? Depending on what your scenario is, will depend on the route we take. As in, do we have logs on both sides? Or do we just have a log on one side? Okay, so we've got 2 different scenarios we're going to be looking at. As we, let's see, it's solve each equation, round to nearest 10,000. That means you're going to be using a calculator as necessary, right? As we look at A, this scenario is we have a natural log of x squared minus 16 equals a natural log of 6x. Okay. I want to say think logically. My brain's logical. I don't know if it will be to you guys or not, but we have a natural log of something on the left. We have a natural log of something on the right. What would make sense if it's a natural log equal to a natural log? What would make sense about their insides? Set them equal to each other, right? Because if it's log same base, right? Natural log, if they are equal to each other, those insides have to be equal to each other. So that's a step we're going to drop off the natural logs, and we're going to set up the remaining pieces as an equation. So in this point, I got rid of the logs. I don't even, well, I guess I do have an x squared, but I don't have, it's not like x is in the exponent. So now you dig into your algebra solving skills that you have stashed away in the back of your brain. How do we solve? When I see an x squared term, an x term, and a number term. You don't like this one, Patrick?
No. Factor.
Okay, see? Okay, we're going to set equal to 0. And then, yes, our goal is, we're going to hope it factors, right? Keep in mind, there's other directions we could go, but I think they do factor today. Okay, so to make it equal to 0, subtract 6x, which means I'm subtracting 6x on the left. How best would it be to write my terms on the left? Okay, x squared minus 6x minus 16. Put it in that ax squared plus bx plus c order. And then, as has been already pointed out, we're going to try and factor. It's just the 1x squared, so it's the easy version, which means when we're going to factor, we're going to break it into 2 parentheses. X squared breaks into x and x. I need numbers that multiply to be negative 16 and add to be negative 6. Yes? Negative 8 positive 2? Once you get your factors, now what? Okay, set each factor equal to 0. X minus 8 equals 0. X plus 2 equals 0. Then what? Yeah, officially it's add the 8, subtract the 2. We get solutions of x equals 8 and x equals negative 2. Should we check for extraneous solutions?
No, because it does have the directions.
But what do we have to?
Here's the deal. If you go back to the original equation, are there restrictions on that original equation? Are there issues of types of numbers that can't happen? And since we're dealing with logs, what have I said about the inside of a log? It can't be negative. It has to be greater than 0. So now, here's the deal. Just because this is a negative 2, that doesn't necessarily mean it doesn't work. Is it going to make either of these logs inside? Negative. And here's what I see. 6 times negative 2 is negative 12. Can you do a natural log of negative 12? No, your calculator yells at you, doesn't it? It says error. So, does negative 2 work? It does not. Okay? Now, don't ever just assume because 8 is positive it works. Because there's a possibility if we plug 8 in somewhere, it could turn into a negative. Now, on this side, 6 times 8, okay, that's a positive. Okay? Over here, 8 squared minus 16, that's a positive. Okay? So, while the directions don't say it on my particular piece, check for extraneous solutions. I honestly don't know if Savas will say it or not. But if you start with a log problem, make sure the insides don't become negative. Okay? And I will even put that. Check solutions. Inside of a log cannot be negative. Okay? There's your reminder. Okay. Have you started B? What's going on with B? We have log base 5 of x squared minus 45 equals log base 5 of 4x. Log base 5 equals log base 5. What's that mean is going to have to be true? Inside equals inside, yes? So similar to the last problem. X squared minus 45 has to equal 4x. Okay? Make the equation equal to 0. How should I rewrite this on the left? Okay. X squared minus 4x minus 45 equals 0. Setting up in this x squared plus bx plus c form. You're now setting up 2 parentheses. See a lot of people, I think, working ahead of me, which is good. X squared breaks into x and x. We need numbers that have a product of
-9 and 5.
Okay, he says -9 and 5. Does that give me a product of -45 and a sum of -4? Okay. So x minus 9, x plus 5. Set each factor equal to 0. So x minus 9 equals 0, x plus 5 equals 0. We get solutions of x equals 9, x equals -5. Are any of these solutions extraneous? Okay, right there, 4 times -5, 4 times the negative is a negative, so that rules out x being any negatives. Can 9 work? 4 times 9 will be a positive, that's 36. Over here, 9 squared minus 45, that's going to be a positive, 81 minus 45. Okay. Did I hear a knock?
Yep.
Okay. I kind of thought I heard a knock, but then I didn't, so I should have checked. Sorry, Adriana.
You're fine.
Thank you. Okay. We got the idea if there's logs on both sides, yes? Okay. As we look at C, and D for that matter, there's 2 logs. And what else? Okay. Well, on C, my logs are on the same side, but here's the deal. There's also a number over there. So think about this. Even if I separate my logs, I'm going to have a log equal to a log plus or minus some number. Am I going to have a log equal to a log? I'm not going to be able to just get it as a log equals a log. Okay, in both of these cases, because there's some other random extra number. Okay, so now we need a different plan. Because I can't get log equal log. On that left, let's employ a different property here. Can we take those 2 logs that are being added and combine them to be 1 log? Maybe I should, since I'm asking can we, maybe I should say how can we? Take those 2 logs and put them together as 1 log.
We add.
I don't like either answer quite exactly. Well, I don't know, kind of a combination. Okay, I don't know.
And feel awesome.
What's the rule? When you add two logs, how do you put them together as one log? What property are we using here?
Product property of log.
Product property, which is where you might be on the right track, okay? Product property says if we take two properties that are being added and we rewrite them as one log, what do you do with the insides? You put them together how?
Magic.
Not magic. The logs are being added, the insides are being multiplied, okay?
The distribute property.
So you're going to end up distributing when you multiply.
So what Paul said.
Huh?
So what Paul said.
I said, well, that's why I tweaked it and said, well, yeah, but I need you guys to realizing we're multiplying, okay? So I'm going to write this. What is my screen doing here? Log base 2, two logs being added, and it's going to be x times x minus 3. I'm taking this as two steps just so I don't, risk losing anyone. Okay, log base 2 of x times x minus 3 equals 2. Now, yes, this is where I kind of backtracked and said, okay, well, yeah, we are going to distribute, aren't we? So, log base 2, what is x times x minus 3? X squared minus 3x. Okay. Well, we're down to one log. We have a log equal to a number. But I'm trying to solve for x, and x is inside the log. How do I get x out of the log? I think mid-yawn you're mouthing it back there. Are you mouthing it mid-yawn?
Yeah.
What was that?
Divided.
Not divide it. That's what I thought. I thought you were mouthing something else.
I think I was just yawning.
Okay.
Whatever he thought he was doing, he was doing.
Yeah, whatever you think I said, I said.
It's actually guessing.
What do other people think he was maybe?
He was just
I
wanting
didn't
you to
see.
guess
I didn't
what he
see the
said.
mouth. So.
3 words.
Oh, left, right, middle.
There we go.
Yeah, that's what I was thinking. But I wanted to make sure you knew.
I was actually testing you.
For some reason, anytime I say 3 words, you guys couldn't come up with it. Okay, here, how do we get the x out of the log? We have to take it to exponential form. Left, right, middle. So what's my left? The base of 2. Raised to the right, what's the right? Exponent of 2. Equal, what's the middle? The inside of the log, which is x squared minus 3x. It's rough back there today, isn't it?
Rough every day.
Okay, are we there?
Or something.
Or if you don't like left, right, middle, the base of the log becomes the base of the power, right? And you flip the other two pieces. So 2 and then equals x squared minus 3x. What do we know about 2 squared? It's 4. I have 4 equals x squared minus 3x. What are we going to do? Okay, this sounds familiar, doesn't it? Subtract the 4 to make my quadratic equal to 0. So 0 equals x squared minus 3x minus 4. X squared breaks into x and x. Multiplying to -4, adding to -3. -4, +1. Set each factor equal to 0. If x minus 4 equals 0, then we know X equals 4. If X plus 1 equals 0, then we know X equals negative 1. Okay. Go back to the very original problem. Okay. Does a negative work? No, because right here I'd have log of negative 1. I can't do a log of a negative. So I'm going to veto that one. Don't ever assume just because there's one left that it works. Don't assume it's positive it works. 4. Log of 4. Okay, that would be doable. Log of 4 minus 3. 4 minus 3 is 1. That's doable. That appears to work. Okay. One more problem for the day. We have 2 logs again, but we also have that extra term hanging around. Can I make this equation log equal log? No, I can only make it log equals log plus 2. So what should we do here? The what? The one property. Well, okay, so last time the logs were on the same side of the equation and we were able to take our product property, yes? Okay, so what should we start with making happen over here? If we're going to want to put those logs together, they need to be on the same side. So we already have a log on the left. Can we make this other log go to the left? Yeah. Let's subtract log base 3 of x minus 1. What I do on the left, we're going to do on the right. So we're subtracting log base 3 of x minus 1 on both sides. So on the left, we already have log base 3 of 3x minus 2. And now minus, we're going to have log base 3 of x minus 1. Equals, on the right, these logs cancel and I'm left with 2. Okay. 2 logs being subtracted. Rewritten as one log where the insides are being divided. So I can rewrite this. It does sound like the quotient property. Log base 3 of 3x minus 2 over x minus 1. Okay. Quotient property. 2 logs being subtracted can be rewritten as one log with the insides divided. I want to solve for x. Where are all my x's? They're inside the log. How do we get them out of the log? Left, right, middle. Okay. Left is my base of 3. Raised to the right, which is the 2. Equals, what's in the middle? That fun fraction of 3x minus 2 over x minus 1. Okay, well, 3 squared is 9. Okay, so I'm at the point of 9 equals 3x minus 2 over x minus 1. I have a fraction here, yes? I don't really want a fraction. I don't want x's in my numerators and x's in my denominators. How do I get rid of a denominator? Okay. If this is 3x minus 2 divided by x minus 1, the opposite of dividing by x minus 1 is to multiply by x minus 1. What you do on one side, you're going to do on the other side. Now, on the left, How do we multiply x minus 1 and 9? You distribute, yes? So my left is going to become 9x minus 9. On the right, what happens? X minus 1 cancels with x minus 1. You're left with 3x minus 2. And this just became the easiest equation we've solved all day? Maybe? Not quadratic, is it? Since it's not quadratic, get your variables to one side, constants to the other. So subtract 3x. How confident are you guys? Can we do it all at once, or should I not? If you subtract 3x, you can also add 9. So 9x minus 3x is 6x. Minus 9 plus 9, I'm canceling. 3x minus 3x, I'm canceling. Negative 2 plus 9 is 7. We have 6x equals 7. Divide by 6. And x is what? I would be perfectly fine with the answer 7/6. Savas, may or may not be perfectly fine with the answer of 7/6, because if I go back up to my original directions, it said round to the nearest 10,000. I usually think of that when we can't make a fraction, but so what is the other answer if I round this to the nearest 10,000? Okay, because it's 1.1 and then the 6 is repeating, yes? So 4 decimal places, it becomes 1.1667. For me, I would be perfectly fine with 7/6. Savas might require the decimal. You never know. Okay. 6.6 is out there and available in Savas, yes? Do it. Get it done. Okay. Tomorrow, I'll be handing out unit review worksheet. If for some reason you know you're not here tomorrow, I would pick it up today so you have it to get working on. There's a lot going on, so it's kind of a lengthy review worksheet. Test is planned for next Wednesday, and SAT is next Thursday. Okay?